So we defined what a derivative is using all of this crazy stuff down here. Now let's see if we can figure out what we're going to do with it. So the word differentiate means the act of taking a derivative. So differentiate a function using definition of derivative means actually take the derivative. And you'll hear that word differentiate a lot. So kind of keep track of that one. So we did all this crazy stuff already, and we defined this derivative, and we said the nice thing about this derivative is we can find the slope of a line you having only one point. And this line, we call it specifically this tangent line. So what the derivative really is really this thing right here. Okay, that's where we kind of went through. Well, what I'm also going to introduce to you today is that this is another way we look at it, and especially AP people, they like to use h's instead of changing x's. It makes it a little bit easier to deal with. So we're going to try to take this derivative. So let's jump to this second page. And on the second page, you got problem number 1. Find f prime of x, find the derivative, using the definition of the derivative. So the definition of the derivative, I'm going to make this a little bit bigger here so that I've got some room to work. So this definition of the derivative, we're going to start, let's write down what that definition of the derivative is that I just put in a box. And I'm going to use the h version. F prime of x is equals the limit as h approaches 0 of f of x plus h minus f of x over h, and we're going to take the limit of that whole thing. Okay, so here's how I start a problem like this. If I got to find this derivative, I'm going to start with my, by the way, you always start with labeling this thing f prime of x, because notice right here it says f of x. We want to make sure we don't confuse it. We're going to do something different here, so don't just give me a string of equal signs. You're going to want to label that now. Okay, now I'm doing something different. I'm taking the derivative. So limit, whoops, we can do it red. Limit as h approaches 0 of, and I like to start here. Let's take this red underline out. I throw in my little minus sign up there on the top, and I kind of look at it that way. So now if this is what you look at, and you go, well, what comes after the minus sign? Well, after the minus sign, according to this, looks like it's supposed to be f of x. Well, what's f of x in this problem? That is. So let's throw a root of x in there. What comes before the minus sign? Well, before the minus sign, it looks like we're supposed to have f of, instead of just f of x, f of the quantity x plus h. So everywhere we see, we're going to go to the f function, which is a square root. And everywhere we see a variable, we're going to replace it with the quantity x plus h. So there you go. So there, we've jumped through the hoop of finding the derivative. That thing right there, after we get done cleaning it up, is going to give you an expression that you'll be able to plug any x value in you want and find out what the slope of the tangent line is at that value. And I'll show you a couple of them when we're done. Because now what we've done is we've changed this from being a derivative problem to being a limit problem. We know how to do limits. So what do we do with this limit? We tried direct substitution. Well, that's not going to work. So then what about our bag of tricks? Well, our bag of tricks, let's try rationalizing this numerator. So let's use our conjugate, root of x plus h plus root of x, top and bottom. We've done a few problems sort of like this at this point. So if we go and we do that, let's take this thing and let's kind of, let's multiply out our binomials on the top. Let's FOIL that out, so to speak. Limit h approaches 0. If we do that, let's see, numerator. We've got an x plus an h. We've got outside and inside terms dropping out. And on the denominator, I'm going to fight the urge to distribute. Okay. Well, now what's going to happen? Well, those two x's that we have there on the top are going to drop each other out. And if they do that, it looks like my new limit. I got an h in the numerator. I got an h in the denominator, which is good because that h in the denominator is what was keeping us from being able to do direct substitution. So let's cancel this h in the numerator and leave a 1. Let's cancel that h in the denominator. Now my direct substitution will work. If my direct substitution will work, I'm going to have a 1 on the top. I'm going to have a root of x plus, it looks like a 0 there, and another root of x put those together. What's that spell? What's this derivative going to be? This derivative is going to be 1 over 2 root of x, and we're done. Now, what did we just find? Okay, so here's the idea. I just found that f prime of x in this problem, f prime of x is the same thing as 1 over 2 root of whatever x is. This is this is kind of your big deal thing right here. This is what we just sort of came up with. That's your big deal thing right there. Okay, so we got it. Now, what do we do with it? Well, let's say I wanted to find the derivative at x equals 1. Well, that would be 1 over 2 root of 1, or 1/2. Well, let's say I wanted to find the derivative at x equals 4. 1 over 2 root of 4, or how about 1/4 by the time we'd get done? What if I wanted to find the derivative at negative 2? 1 over 2 root of negative 2, which would mean that this thing doesn't exist, because we can't take the square root of a negative number. We just use this derivative to find us an expression that we can plug any x value in we want to come up with the specific slope of that tangent line at that particular point.